I left my
We are
phone
live.
just in case.
Welcome everybody to this new episode of Rust live coding session with the B team. So a little warning, today I'm at home and I have a really bad network, so let's see what happens. Maybe so there is at the moment Christian in the chat. I'm not sure the microphone is working. Can you try to speak?
Hey,
Yeah.
sorry, I had a
So,
small connection
but
problem.
can you guys hear me at least?
Yeah, I can hear you.
So maybe someone in the chat can say if they are hearing me or not.
Just a sec.
Alright, so nobody's answering, so this is a bit worrying. I'll try to leave the chat and come back. Can you hear me now?
I just checked the audio and it's working on the live stream.
Alright, so I've been told that you can hear me on YouTube, but for some reason the vocal chat with the team is not working. I probably don't have time to investigate that now, so unfortunately I don't think you'll be able to hear the colleagues. So yeah, too bad. Yeah, so today I'm going to speak about hashing. So the past few days we have been investigating ways to increase the TPS of the B node. There are two aspects for that. There is the hashing. So you know that when you want to send a transaction to the IOTA network, you have to hash it. You have to do proof of work. So you have to repetitively hash the transaction up to a point where the hash ends with a significant amount of zeros. So this is proof of work. And this is a time-consuming operation. So as a client, as a user, you only have to do that once to send your transaction to the network. But server side, you have to verify. You have to verify all of these hashes, but you have to verify a lot of them from basically all of the network. So this is a very time-consuming operation. The current hash function for the IOTA network is curl with 81 rounds of transformation. So one of the aspects of improving TPS is to improve the performance of this hash function. I think it has been done to the best we could, but the next step is to batch the hashes. So at the moment the B node is only hashing one transaction at a time, but there is a technique that we'll see today to hash 64 transactions at a time. So that's what we are going to see today, and the other main area of improvement for increasing the TPS is to increase the actual synchronization logic. At the moment we synchronize one milestone at a time, but we can synchronize many milestones at the same time asynchronously. So we have been working on both at the same time during this week. So I'm going to give a quick overview of what it means to batch hash. Alright, so I have this thing open. So it's on one of our developer, Luca Moser, on his personal GitHub. It's a nice little reading about batch binary encoded ternary curl. So I'm not going to go in full details of what exactly is supposed to happen in all of these operations, but the main thing to understand is that you use an array of integer and you pack so The audio is low. Yeah, maybe my voice is low. I'll just. Alright, come closer to the microphone. Yeah, so instead of just using one transaction, one buffer for the transaction, what we do is that we use an array of integers, 64 in this case, and we use it to pack 64 transactions in it. So you can have a read if you want. I'm not going to detail everything. But yeah, the main goal is to have this array of integer and to pack the transactions inside. And when you apply, when you know that you maybe know that curl is a sponge construction, so it follows the pattern of absorbing and squeezing stuff. So this version does the same, but when with simple curl you absorb and squeeze on a simple buffer, here you apply the same transformation on 64 objects at the same time. So yeah, so there is this first operation that is called multiplexing, which is the fact of packing all of these transactions into these integers. Then we can absorb, then we can transform and squeeze, which are the classic operations of sponges. And at the very end you can demultiplex, so get back your hashes out of the integers. Yeah, so Luca also has an implementation, a Java implementation on his personal GitHub. I invite you to have a read if you want. But if you want another implementation, there is one in either IOTA.go or hive.go, I don't remember. But yeah, they use it in Hornet, in the Hornet node. So you can have a look at the other implementation. Yeah, so now if we go to B, Christian for the team has been working on that, on batch hashing. So what I'll be doing today is not actually implementing batch hashing in Rust, because it has already been done by Christian, but what I'll do is to use it in the B node. Basically replace the single version of curl with the 64 version. So I'll just go to the forks and see if I can find Christian. Is there? He has some branches and he probably has, yeah, so that's the one we are going to work on. Alright, so this is my editor. So what I'm going to do is to alright, so there, for example, something like that. Do we have? Nope. Yeah, so this is BP, so this is the experimental version of B. It currently uses the dev branch of the actual B repository, but since this version of curl is on at the moment on Christian's fork, I'm going to replace all occurrences of that with Christian's one. Alright, so this with, alright, this was already been done. BTC curl, alright. Alright, so now everything should be on Christian's fork. Just trying to see if it compiles. Alright, looks like it's compiling. So now I'll give you maybe a small introduction about the transaction pipeline. So what happens to a transaction from the point where you receive it to the point where you process it. So the main worker here is the peer worker. Alright, so maybe I'll just shut down this, reduce this. Yep. All right. So the peer worker is the worker that receive a plain message, so a byte message from the network, parse it, analyze it, and depending on what kind of message it is, send it to a specific processor. So you can see that, for example, depending on the message type, we do a match, and then for each kind of message we dispatch the message to its own processor. So for us, what's interesting is this part, this one. So you can see that we parse the message from bytes with the TLD from bytes operation, and then we basically send the event to the transaction worker event. So it looks like my network is a bit laggy, sorry about that. I hope it's fine. Yeah, so now we are going to have a look at this transaction processor. So yeah, so this is the main transaction processor. Receive the transaction here. It received the transactions, send them to this operation, this function. So what it does, when we receive the message, it's still in bytes. So first thing that we have to do is to convert it to T5B1. That's a specific encoding of tricks. When we have that, we can encode it to T1B1. That's another encoding of tricks, which is 1 byte equal 1 treat. And when we have the treats, we can finally create the transaction. When we have the transaction, we can hash the transaction to get the hash out of it. So you can see that we are using kernel here to digest the treats, and that's where we have only one hash at a time. So that's probably where the new batch hasher is going to be put. And then after that, when we have the hash, we can, for example, check that the hash has the right amount of proof of work. So we check that the hash is ending with enough zeros, depending of the configuration, MWM, minimum waste magnitude. And then when we validated that, we do a lot of operations, but basically the main stuff that is important is that we finally insert the transaction in the tangle. So that's the most important operation here. The way I'm going to do things is that I'm going to split this worker in two. So the first worker will just be a hasher, so it's going to accumulate 64 transactions, and when we will have 64 transactions, we are going to hash them and then dispatch them to a second worker. So I'm going to copy paste this worker. I'm going to rename this one hasher. I'm going to rename this one processor. Alright, so hasher and processor. So I'm going to rename transaction worker to hasher worker. And I'm going to rename this one as well to processor worker. Alright, so now it means that I have to change something in the module. So this is now hasher, this is now processor. So this I can copy paste it, change that. This one will be hasher. hasher worker, and this one will be processor worker. Alright, and now I can probably here, yeah, I have to change that as well. So this is now hasher, and I have to add the new one, processor worker event. Alright, so there are probably some place I was using there, probably in the protocol, so I need to change that as well. So this is now hasher worker. Alright, and I can add processor worker event. Alright, so this is the protocol file. So this is where we actually create the protocol. So that's where we spawn all the different tasks that compose the protocol. So since I created a new worker, the protocol worker, I have to create the new task for it. So I have to create new channels, I have to spawn the task. So I'm going to do that now. So this was the previous worker as well, so I'm going to rename it hasher worker. Alright, so I'm just going to copy paste the hasher worker channels. I'm going to rename, I'm going to rename it to protocol, processor, sorry. Oops. Alright, yeah, I'm not going to change the configuration at the moment, so I'm just going to put a dump size, and I'll change the configuration if I have some time after. Now what do I want to do? So we have the hasher worker, so we now have the processor worker. Alright. Yeah, so it wants me to add it there as well. Processor. Alright, and I'm going to copy paste. So this is where we spawn the hasher task, so I'm just going to copy paste it as well. Change protocol here, processor, sorry, processor and processor. So why is it complaining? Yeah, because I haven't changed this as well. So processor. Alright. Yeah, so let's not change the name of this one for now. Alright, so now everything is set up. I have my two workers, but they are basically doing the same thing. So now I'm going to split them and check what should be done in which one. Alright, so this is the hasher worker. What I wanted to do, so for example, we are not going to do any kind of validation in the hasher worker. So it's just supposed to accumulate transactions, hash them, and pass them for validation to the processor. So this function will not be used in this one. So we can remove it. Now this part is where we so we have a small cache in this one. It's going to stay there. What it's doing is that we are using another function, hash function. I think it's XX hash. It is definitely not cryptographically secure and probably not collision secure as well. but since the size of the cache is really small, it's just for a short amount of time, so the probability that a collision is detected in a short amount of time is almost non-existent. So it's fine to use this one. Then we have this part. We are probably going to keep it because that's where we parse the bytes and where we do actually the hashing, so we are going to keep this one. But then we have that, and that's already a validation thing, so we are going to keep it for the next one. We are not going to check if it has the right amount of proof of work. And basically everything that follows is either validation or tangle operation, so everything after that we are just going to remove. Alright, so now we have this more thing. Alright, so let's see what we want to do. So here there is the actual transaction creation. We don't want to do that here as well because that's already validation, because it can fail depending on the content of the treats. So we don't need that here. So we are going to remove it, just keeping the hashing part. Alright, and now we don't have the transaction anymore, but only the hash. Alright, so that's what it would look like. So now I'm going to go back to Christian repository and see what the API of it looks like, of the batch hasher. Sponge, batch curl. So this is BTC curl, and I guess, yeah, so batch hasher. So I'm going to import that, use crypto sponge, so that should work. It does not. I guess the module is not exported, so I have to batch curl. Yeah, alright. So yeah, now I'm going to replace the curl p81 by these things. So I'm going to curl it bcurl. I will have this, and I will just remove the previous version, so curl p81. Alright, so now I need to change that here. Batch hasher. So what are the parameters of batch hasher? It takes a hash length. So 243 is the hash length of transactions, and rounds. So that will be 81 for us. So we have a constant that I'm going to use, and we have this. So hash length, I think it's in big crypto. Should be fine if I do that. Yes, it is. Alright, so now I have this batch hasher. What can I do with it? So the way it works, here we have an example here. So we create the batch hasher here, and here we process it. So if you look at the parameter, there is only one parameter to the process function, and it takes a vector. So yeah, you have to accumulate the transaction in a vector, and then, well, it gets a slice, but the way it's done here is that it's through a vector. So you accumulate in a vector and you give the slice to it. So yeah, I'm going to do something similar. So I will need an accumulator as well. Alright, so accumulator, that would be a vector of treat buff, I guess. Yes, treat buff. So treat buff, and that's in bternary. Alright, so now I need to create the accumulator. So what you want to do is to already allocate the maximum capacity, which is 64, so that you don't have to allocate it later. So the size will be allocated at initialization and not after. So there will be no more allocation for this vector after that. So 64, because that's the amount of transactions we want to hash at the same time. So now, instead of directly hashing, we are going to just push in the accumulator. So self accumulator dot push, oops, and we are going to push the buffer. Alright, and we are not going to, I'm just going to comment that. Alright, so now what's happening is that transactions are coming through the network. We are pushing them in an accumulator, so it's rising time after time, and at some point it's going to reach 64 of length. When it does reach 64, it's when we want to actually process the whole stuff. So I'm going to remove this function because the name doesn't make any sense anymore. I'm just going to call it add transaction, and what I'm going to do is if self.accumulator.len equals 64, I'm going to call another function self.process transactions. Alright. Yeah, it will probably be asynchronous, since when the hashing will be done, it will send the transaction to another worker, the processor worker. So it will probably be asynchronous. So I'm going to await it, and then I'm going to create this function async fn process transactions with an S. Alright. Mute self. Alright, so what exactly do we want to do here? Then we want to process the transactions, and we are going to give it a slice of the accumulator, self accumulator, and a slice of that. Alright, when it's done, there are two things we want to do. We want to send the hashes, send the TX hashes capitals to processor, and we also want to clear the accumulator. Since we have hashed everything, we don't need them anymore, so we clear the accumulator so that its length goes back to 0, and so that we can start accumulating transactions again. Yeah, so let's start doing that. So self.accumulator.clear. Clear only remove the elements, but it doesn't change the capacity of the vector. So the capacity will stay 64, and there will be no more allocations of memory. Alright, so I'm doing that. I think process returns the hashes. Where was process? There. Yeah, it returns the hashes. So we want to do let hashes equal to that, and now we can iterate on the hashes for hash in hashes. Alright, so we'll make a first stop. I'm just going to print the hashes just to check if everything is fine. So yeah, since the hashes are now treats, I have to convert them. To tries so that we can easily read them. I'm just going to copy paste a bit. Alright, that's alright. So I'm good. Alright, that's So this will convert the hash to tries that we can easily read. Alright, I'm just going to compile that quickly. I saw some errors, so let's fix them and then we'll have a first try of it. So peer worker, so there is something wrong in the peer worker. Yeah, I haven't changed that, so this is now the hasher. There was another error, so this one is as well. Alright, was there any more errors? It's a bit slow. But I think it will be fine, so I'm going to hasher worker, so I'm going to commit that. I'm going to go to my VPS and I'm going to try it with in the network, I mean. Oops, I just committed that to master. This is not what I want to do. Alright, I'll just clean master afterwards. Alright, so now I am going to go to, now you know what, yeah. Alright. It will be easier to work on this one. I'm going to push this one. I'm going to go to my VPS. As last time, I'm not going to show you the very first run, the beginning of the run, because you may see some IPs from my peers. But as soon as it will be done, I will launch it, I will see it. Alright, so this is compiling at the moment. So yeah, while this is compiling, this one is basically done. The only thing, the hasher worker is basically done. The only thing we need to do now is to send the couples of transaction and hashes to the processor worker. The annoying thing is that we also need to send the from and transaction message, because we also need them in the processor. So we may need a second accumulator or something like that to be able to keep track of which from is with which hash. Alright, so this is done compiling, and we now have some stuff. So this is running. I can show you that. So we see some hashes. Alright, so what you can see happening is that from time to time we have a bunch of hashes appearing because we wait so that we have enough transactions to hash them. You may see that the incoming may seem enough to have more, but you also see that the noun is not zero. So in the incoming transactions we have some noun transactions, so you have to subtract them from the incoming and then you would have the right amount of transactions. So just to check that The hashes are fine. I'm going to copy paste one of the hash in rectangle.org. So this is the hash I just copied from it. Alright, and it seems like it's a valid hash, and it's a hash that is only 40 seconds old. So it's definitely valid. Alright, so now that we know it's valid, we can maybe start pushing that to the second worker. Alright, so the first worker, the hasher worker, will have to need a way to push transactions to the second one. At the moment it doesn't. It will probably need a channel. So, by the way, this channel is not used anymore, so I'm going to remove it because it's part of the processor and not the hasher. So probably this is failing here now. Yeah. Alright, so the hasher needs what does it need? Alright, the hasher need the sender, so it needs something like that. So alright, I'm just going to call it processor here. So it needs a channel to communicate with the processor worker. So this is the one. I'm going to put that as parameter as well, and then have it here. I need to include processor events. I think we may have it here. Alright, so now this is fine. And it needs this one. Alright, we probably need to clone it here. Alright. Yeah, just want to mention that you can see that the new part of the TPS was 0 because we were not sending anything to the second worker. So when we are done with this, we should start seeing the new part increasing. Alright, so this is fine now. We have a way to communicate with the other one. This is the other one now that we haven't touched so far, so probably some things we can remove. So what we can remove is, for example, the cache. We don't need it anymore because it's part of the hasher worker. What we can remove is also curl. We don't hash in the processor anymore. This was part of the cache, we can remove. Alright, and now we had the previous part where we computed the hash. We don't need that anymore. The hash will come from the channel. So I'm going to remove from here. So now it will only be transaction. We don't hash from here. So here we just remove that. Right. So now it complains because we don't have the hash anymore, but the fact is that we are just going to add it here because it will come through the channel as well. Alright, then we need to, when we deconstruct the event here, we need to add the hash, and we are going to pass it to the method. Hash. Oops. So now it doesn't complain anymore that we don't have the hash, and I think basically everything else in this worker is fine. Let me double check. Here we check the minimum waste magnitude. Yeah, everything else is fine. The only difference was the way we acquire the hash. Previously it was through the hash of simple curl 81, and now it's through the channel, but basically everything else is fine. So some things are not being used anymore, so I don't need to import them. So removing some stuff unused, we can basically remove everything here. And yeah, we don't need this parameter, so probably something is going to break here. Yeah, we don't need that. Alright, and probably here too we can remove a lot of imports that are not being used anymore. So let's do that. Just a bit of cleaning. Nothing is being... I think I'm going to use this one, so this one... we don't need that as well, this not. Alright, so now we want to actually send it. Alright, so what I'm going to do is self processor dot send. Now we want to construct a processor worker event. Processor worker event. We want to give it all the information. So that will be a hash. That will be a from, and that will be the transaction. Is that what it? Yeah, transaction. Alright, so as you can see in this function we don't have the from and we don't have the transaction anymore. The annoying thing is that we wait to have 64 transactions to pack them before sending them. So there is no other way than keeping track of all the from and all of the transaction bytes as well. So we need to keep track of this as well. We need to hash everything, and when we have all of the 64 hashes, we want to send hash from and transaction at the same time to the channel. So basically what we have to do is to have another kind of accumulator to be able to keep track of from and transaction. So what I'm going to do is to at the moment, maybe this will change at some point, but I'm going to have another vector. So accumulator becomes a pair of vectors, and here we'll have a pair of endpoint ID and transaction message. Alright, so now we need to change that. So this is now a pair, and this is a pair of two things of the same sizes, so 64. This is now fine. Of course some things are going to break, so now it's requiring us to tell it which part of the pair we want. Actually we don't really care because I will always have both the same size. Right, I'm just going to put that away. Alright, sorry. Yeah, so this one push, so we also want to push this one in the first one, and here we want to, so now we want to clear both at the same time. So yeah, we have to remember to clear both vectors. Oops. And this one is still 0. Alright, so now what's happening with this one? Oh no, the 0 is here. Alright, so when we push the transaction, we also want to push the from and the transaction message. So self accumulator one push, and we are going to push a couple of from and the actual transaction message. Alright, here we don't need the return anymore. Alright, so it means that now here we have access to everything. So we can actually do that. So The hash, we need to construct it because we need a hash, real hash type, but what we get from the batch hasher is just treats, so we need to convert the treats to a hash type. So what we are going to do is from inner unchecked, I'm using an unchecked version of the function here because we are sure, because of the implementation of the batch hasher, we are sure that it always outputs valid treats, so we don't need any kind of validation on the input, so it will be way faster like that. From hash, alright. Now the from is self accumulator 1, and now I need to index the vector, but I don't have any index, so I'm going to add an index by iterating with an enumeration. So you can do that and then you get back an index and what you are iterating on. So now I have an index, index, and what I want is the first element of the pair. And the transaction is the second element of it. So what's happening here? So do I need to... Yeah, so since this is asynchronous, we need to give proper ownership to the channel and to the worker, so we won't be able to... so we have to clone this hash.
Hey Thibault,
Now this
I
is
think you can
annoying.
actually do something different there, and you
Cannot move
can
out of
instead of
index. Yeah,
instead of
so now
calling,
this is the same thing as the hash that I just told. We need to give proper ownership to the channel. So I could just probably clone. It's probably not implemented on this type, but the fact is that the transaction is rather large. So I don't really want to clone it. And the thing is that I won't use it anymore after, so we already have an ownership of a transaction, but it's currently in this accumulator. So if I could, for example, if I could do something like that, no-name pop, for example, maybe I can, yeah, no, I can do that.
hey Thibault, can you hear me?
Yeah, so what I'm trying to do is to get the actual thing out of the vector, so that we can give the real one and not a copy. But for some reason, let's take your so what am I doing wrong here? So this is the second accumulator, right? Second accumulator, this is now a vector, so I should be able to pop that. Yeah, so this is working. So the type of that would be a pair, so I should be able to do that one. Oh, but pop surely returns an option. Alright, since we are iterating at the same time as the hashes, we know that they have the same size. We know both accumulators have the same size, so it is perfectly fine here to actually unwrap the pop.
Hey Thibault, can you hear
And
me?
now I can access the elements. So now I have a transaction and I can give it here. Alright. So this is working. There is an issue though. A vector is actually a stack. So by doing a pop, you would not get the first element. You would get the last element. So this is a bit annoying. So to have the behavior I want, which is by popping, I want the first element, because by iterating on the hashes we get them in the right order, but by popping we get them in the reverse order. So instead, for the second one, instead of using a simple vector, I'll be using a vectaker. I'm not sure where that's supposed to be. Use std collections. So this is basically a queue. So now this is a vec probably some things. So with a vec queue, you have the options where you want to push at the end of at the back. So when we push, we want to push at the back, and when we pop, we want to pop at the front. All right. So this is now fine, and that's the correct one. Oops. Yeah, I should. All right. So removing that, there is this one. All right. This is asynchronous, so I need to actually await it. Otherwise, it's not going to be picked up. All right. I think that's it. I think now we are doing everything. Maybe one last compilation before we try live. All right, it's already compiling the node crate, so I guess it's fine. So I'm going to processor worker. I don't think I missed anything. I think everything is fine. Just double checking. It's complaining here. I'm not handling the result, so probably I want to do that to handle the rest. Yeah, otherwise I think everything is fine. Yeah, it compiled, so I'm going to go back to the VPS, going to pull everything, going to compile it again. Alright, while it compiles, there is one last thing I may mention. Yeah, so you will probably see it in the logs, but this part here is a bit annoying at the moment, because what it means is that we are waiting to have precisely 64 transactions to hash them. This is perfectly fine where you are synchronizing. This is fine if the TPS is quite high, so you would always have 64 transactions and you would never have to actually wait. But on low TPS, when you are not synchronizing, what it means is that you may wait a bit to process your transactions. So let's say there is 1 TPS, you will basically have to wait 64 seconds to process the transaction. So that's definitely not a behavior we want. So what we will do at some point, because we won't be doing that today because we don't have time anymore, but we would have an OR condition, and we want to check if there is something remaining. We want to check if there is something remaining in the channel. If there is something remaining, then it means that we can still process something. If there is nothing left, it means that we can already hash the transactions. Alright, so it seems from the logs, oops, that I did a mistake somewhere. Yeah, you know what, let's do something like that. Let's how do I do that? From transactions, I'm just going to, it will make things easier. Yeah, because yeah, you see the mistake. I'm still using the index here, but I'm popping here as well. So by popping, I mess up with the index. I should have used the same thing here. So what I'm going to do is to take that, so pop front and wrap, I'm going to do that so that I get from and transaction at the same time. And now I can do something like that. Alright. Fix out of bound access. Sending that as well. Yeah, just showing you maybe the actual log. Oops, you can see it. Yeah, you can see at the very top that there is a panic, out of bounds access. Alright, I'm going to put it again and now it should be fine. So compiling once again. Once this is compiled, we don't have time anymore, so this will be the end of this stream. So if you have any questions, you can start asking them in the channel, and I will take some time to answer them. Yeah, I am sorry that the microphone is not working for the colleagues because we have Samuel and Christian in the chat as well. Unfortunately, for some reasons, they are not able to speak today. Yeah, so sorry about that. This is the first time I stream from my place, so I will probably have to improve some things, and the network is not that good, so sorry about that as well. Yeah, feel free to ask some questions while this is running. Alright, this is almost done. Alright, yeah. So you can see that now we have finally some new transactions. Yeah, so incoming 35, new 64. So you can see that this is definitely still not ideal. This is only one way to increase the TPS, but given what I said earlier about these little things that we have to wait, it makes it a bit slow as well. And it definitely has to be paired with the new synchronization mechanism that Christian is working on. So yeah, the thing is that what it says on this page from Luca, it says that the simple version of curl is able to process 320 hashes per core per second. I guess he was speaking of the Java implementation. In Rust, we saw that we are able to do 500 transactions, hashes per core per second, and we are still working on the implementation of batch curl. So I'm not going to speak numbers now about this one, but what Lucas says on this one is that they can reach 15,000 transactions per second. So yeah, so that's the goal as well for the Rust implementation. Alright then, I think that's it for today. That's the end of the stream. Maybe I'll stay a couple of more minutes if you have some questions. Art compression sounds in the background, maybe the fan. No, I actually think that's my computer. Alright, seems like there are no questions, I think. Yeah, it does. It does as well. The thing is that I am streaming with the maximum quality I could. So OBS is a bit CPU consuming. At the same time, I'm having my big screen, so yeah, and compiling Rust, so yeah, my laptop is a bit burning at the moment. What's the difference between batches and bundles? I guess you mean bundles. Bundles are just the way transactions are organized to make sense between themselves. So if you want to have, if you want to make a token transfer, you have to create a bundle, which is a collection of transactions, but that's not the same thing as a batch. When I was speaking of a batch, it's just packing transaction in a very specific format so that we can hash them all together. So yeah, there are different concepts. Bundles is just the IOTA format, and batches is just a way to pack transactions to hash them all together. When moon soon I guess. All right then, no more questions. I will leave you here now, and yeah, next episode next week. So see you next week. Thank you for joining.